I did a grading. At this point, I complete grading for the first 23 questions. Last 2 questions, because relatively complicated, so I need to really look at your solution details carefully. Okay? I try to follow your logic, so I need a little more time to complete the last 2 questions. Yeah. But it should not take too long. Yeah. So I can, after the class tonight, so I will complete that quickly. Yeah. So now I want to go through the questions that you have relatively more problems. Overall, you did quite well. Yeah. So overall, for the whole class, so you did quite well. Yeah. So only there are a small number of questions I need to explain. Yeah. So mainly the hard questions, the relatively hard questions. The last 2 questions, the hardest. Oh, another thing. After our class, after this class, I will post my solution file. Okay, yeah. So I have a PDF, answer keys, solutions, including all the details. So I will post. I will create a module called Midterm exam module. I put it on top. So I will put a part A and a part BC together. Because BC, 15 questions, I put them in one file, one PDF file. Yeah, I do not need to separate. Yeah. So what you see, part A, that is quiz number 3. Then another assignment called part BC. Then I post the PDF file, 15 computation questions. So after, probably a few minutes after 8 o'clock, yeah, because I need to upload my PDF file, or just a few minutes after 8. Quiz A already available. Quiz A, I set the starting time at 8 o'clock. So after the class, you can see part A first. Then about 5 minutes later, you will see part BC together. Yeah. So that's the, arrangement for midterm. All right, so let me start. Yeah. All right. Yeah. Let me just give myself a little more space. Yeah, I need to write it. Get a comfortable position to write my handwriting. Yeah. All right. The remote control not necessary, because today I do not need to do a PowerPoint slides presentation. I just do writing on this PDF file. All right. Oh, yeah, what's wrong? By accident? Yeah, disappears. Let me bring it up. Bring it up. Oh, it's gone. Yeah. I need to, why? So sensitive. So sensitive. Oh, here, right here. Bring it up. Yeah, loading. Yeah. Let me try this one. Is it this one? Or this one? Yeah, review this file. All right. Yeah, because I will post the solution file. Some relatively easy questions, I do not need to spend time. I just focus my time on relatively hard questions that I feel I need to explain. For the remaining questions, you just study my solution file. All right. Another thing, preparation. Let me bring up the chat area. So when you type anything, any question, when you type anything, I can see immediately. So if you have questions, either speak or type, so I can give a response quickly. All right. So for the first 10 concept questions, you did quite well. So I do not have much to explain. Let me see. Good. Number 3, one student missed number 3. The answer is false, although, remember, the higher the degree it has, the more we call it principal, right? But this statement is not 100% correct. There are exceptions. And we use the prime factorization. Remember? Prime factorization as a counterexample. This statement not correct. But one student missed that part. So you should be very careful. Because in this coming part A, midterm part A, you will see similar questions, similar to this one. So the point here, you should be careful. So this statement, you should be careful. Okay, similar questions. All right. Then another question. This question. So So here my label is wrong. Many of you noticed that. It should be B. B. 10. That's the correct answer. But I hope you know how to get 10. Because I didn't see anyone gave me the details how to get this 10. So I hope you know it. Because in the midterm, I will give you a similar question. Similar to this one, but it is in part B. I make it a computation question, so not a multiple choice question. Because multiple choice question you can guess, right? Some students, so they, based on some related information to make a guess. But this time, in my question, I do not give you any options. You need to find the answer. So that's the difference. Because I worry for some of the students, you may not know how to find it. So here the main part for this part, although the structure closely related to the Horner's rule, but we common factor out. Common factor this x to the 11th common factor. Then inside 2 x to the 8. Then 16. And that. So this structure. But in your preparation, you need to calculate x to the 11th, x to the 8th together. Because when you calculate these two numbers together, you can share some resource. So here, because when you calculate these two numbers, some of the resource can be shared. So in that way, you can save some multiplications. Okay, So that resource sharing idea. Later, we have another question. so that later, so we calculate special polynomial. So we will have this kind of idea another time. All right, yeah. So that's this question. If you want me explain more, you can let me know. Yeah. Otherwise, I just based on my own understanding. Yeah. Yeah. The last three questions. Yeah. Let me explain last three questions. Yeah. Actually, last three questions. Number 8, you did well. Yeah. So I didn't see anyone miss number 8, but number 9. Number 9, correct answer is A, not B. But I saw 2 students miss that, not a B. Yeah. Yeah, because you need to do the calculation. Yeah. For the concrete numbers, this N is a concrete numbers. You do not know, if you do not do the calculation, how do you know which one is larger, which one is small? Right? Yeah. Yeah. So here, let's do a little bit. Yeah. So 100 to the 2. Oh, why so messy? Yeah. So let's handwriting. Let me change the pen. See if I can do better. Yeah. All right. 1. Oh, still. Oh, not good. Yeah, even worse. This pen even worse. Yeah. Yeah. Let me just try my best. 2 to the 10. Right. Right. 100 is 10 squared, right? 10 squared. 2 to the 10. Based on the algebraic property, what's the algebraic? A to the m to the n equals the exponent multiplication. Based on that, 10 to the 2 times 2 to the 10. Yeah. Okay. Yeah. Base 10. Then when we take log of base 10, it's the same base. Log of base 10n. So we only keep the exponent part. 2 times 2 to the 10. Yeah. Yeah. 2,000 something, right? 2,048. Yeah. 2,000 something. Let's look at this one. This one, to the 10 multiply 0.001, right? Yeah. So that is 10 to the 2 times 1024 times 0.001. So what's that? Okay. All right. So equals 10 to the 2 point something, right? 2.024, right? Yeah. Just slightly greater than 100. That's 100, but here it's 2,000. It's much larger. A little larger than 100. That's difference. So in that way, answer is A, not a B. So you need to calculate to compare. Yeah. All right. Number 10. Yeah. Number 10. I noticed one student missed this. Oh, more than one student. Yeah. Actually, at least 2. Yeah. Based on my impression, at least 2. Answer is C. Yeah. 2 or 3. Yeah. Actually, 2 or 3. One student interpreted this option B in a wrong way. So one student interpreted it as log base n of n squared. That's different. Put square inside the natural log. But here, we need to do square outside natural log. That's different. Two different functions. So then pick the wrong answer because you changed the question. Wrong answer. Right. Some other student pick other options. For things like this, because some student, the hard part is when they compare the natural log expressions a little hard. Because using our result, we can exclude option A, option D easily by our existing results. But these two, very easy to get confused. So here, there is one way to simplify it. Because too many nested natural log, right? So here, the nested natural log, so make it a little harder to see the real function part. Here, I can give you one suggestion to improve your view to see the functions. Because in part A, you will have a similar question, similar to this one. So my suggestion is you introduce a variable, let x be this natural log. You do substitution. Because after substitution, so you can simplify. The option B, that is x squared. Okay. Option C is x times natural log of x, right? Then you can see much easier. You compare x squared and x times natural log of x. So you know this one has the lowest order of growth. So in our part A, new question, if you feel hard to see which one is larger, smaller, so one way you can do this kind of substitution to reduce the levels of natural log, because you may have nested natural log functions. All right, so that's the part A, concept questions. For part B and part C, so I skipped some easy questions. I need to move up. So what's wrong? My screen. All right. So this question is number 2. Number 2, I saw 2. At least one. One I know. And 2. The answer is 3 comparisons. 3 comparisons. Oh, actually 2. One student gave me 4. Another student gave me 6. 6 too many. 6 comparisons too many. So here, answer is 4. So if you draw a diagram, x2 greater than x1. x2 also greater than x3. Although there are many different ways, but the one way is you do one comparison between x1 and x3, you can get these 3 elements sorted. So we can assume, because x1 larger or x3 larger, these 2 cases are symmetric. So we only need to consider one of the 2 cases. Let's say this case, after one comparison, sorted. Then you have x4, you need to find the second largest. Okay? First comparison between x2 and x4, you get the largest, right? So after one comparison, so our comparison number 2, you get the largest. Okay, all right. Then, because we consider the worst case, right? We always consider the worst case. For worst case, x2 should be larger, x4 should be smaller. Yeah. Because x4 is larger, then we're done. Yeah. Because x2 is the second smallest. So now we want to work on the worst case. That is x2 largest. So we need another comparison between x3 and x4. That's why we need 3. Yeah. 1, 2, 3. Yeah. Yeah. Many students give me the answer 3, but I didn't see their details. Yeah. They didn't give me the details. Yeah. Some of students gave me detail, but some didn't. Yeah. So I don't know. How did they do it? Yeah. So here I give you the detail, but this is one of the solutions. You may have different solutions. Yeah. So it's okay if it is correct. So no problem. All right. Number 13, very easy. All of you got this one. Yeah. Number 14. Yeah. Number 14 also pretty easy. Most of you got this one. The answer is 9. Yeah. But here I want to explain one special point. One potential error you may make. Well, I didn't see in this assignment, but in my grading of the previous semesters, many students, not here, but later, they did a lot of errors. So here I think I give you some warning. Yeah. Potential, that's the potential problem. Yeah. That's about the given condition, this condition. All right. First, we know without given condition. First, we ignore the given condition. Without, so we can apply our formula directly. Yeah. So this is our formula. Minus 2. N equals 9. N is 9. Yeah. We plug in. Right. 14 minus 2, 12. All right. Yeah. Then we look at these, the given condition. The given condition you can see equivalent to, so here we use the given condition equivalent to three comparisons, right? Yeah. The given condition equivalent to 3 comparisons. That means in these 12 comparisons, 3 of them can be saved. 3 can be saved. Yeah. So then the total 12 minus 3 equals 9. Yeah. No problem. Yeah. Perfect. Yeah. Yeah. So most of you did in this way. Yeah. That's perfect. But here I want to point out potential problem. This way, if you do it here in this way, no problem. Perfect. Perfect. But if you use this method not in an appropriate way, because later we will have slightly different questions. I will change the conditions slightly different. Then, based on my grading in the previous few semesters, many students did it in a wrong way. So here I want to point out that wrong way thing. All right. For example, here I use a special example. This example for the condition part. So I changed the condition like this: x1 less than x2 less than x3. When I change the condition in this way, several students, they still use this equivalent approach. Equivalent approach. But in this case, if you use the equivalent approach, it is wrong. Yeah. Let me explain why it is wrong. All right. First, when you see how do we get this inequality, yeah, people may argue you need 3 comparisons to get this one. Yeah? So people argue 3 comparisons. In order to get this inequality, 3 comparisons. Because 2 in best case, 3 comparisons for the worst case. Not best case. 2 comparisons for the best case. Yeah. So for the worst case. But you cannot say this condition is equivalent to 3 comparisons. Why? Yeah. So here, I want to point out this. Because if we use 3 comparisons, we can do more than this. We can do more than this inequality. So you cannot say equivalent. More information than the inequality here. Why more? Yeah, let me show you why more. So why more? Okay, all right. Let's recall the last time I talked about the tournament method, right? Yeah. So let's recall the last time I introduced this tournament method on 4 elements: x1, x2, 1 comparison, x1 winner, 3, 4, 3 second comparison, and the third one, let's say 1 comparison number 3. You can see after 3 comparisons here, after 3 comparisons, what do we get? What do we get here? The information we get: x1, x4, or x3. Yeah. In this chain, ordered chain, x3, x4, but there is another branch. x2 is below x1. You can see 3 comparisons, we can get information. This is the information we get. Other than that 3 element ordered chain, we get extra information. x2 is less than x1. So here you can see what I mean is the information we get from 3 comparisons is more than this 3 element ordered chain. So that's why I said they are not equivalent. They are not equivalent. Yeah. So if you use this equivalent approach to answer the question like this, you have a good chance to get a wrong answer. Yeah. So that's the potential problem I pointed out. Yeah. So later when you use this equivalent thing, you should be very careful. You really need to think if the given condition is equivalent to a certain number of comparisons. Oh, yeah. So here, my suggestion is, when you get the comparison, the inequality separate. Here you have separate, right? Yeah, x1 less than x2. The first inequality is completely unrelated to the second inequality, right? So these 3 inequalities are completely unrelated. In this case, if you use that equivalence idea, you have a good chance it's correct. But not separated, yeah, because here, 2 inequalities are closely related, when they're closely related, then you cannot use the equivalence idea. Yeah. The problem. For future problem, yeah, not for this assignment. This assignment, because you didn't see the relatively complicated conditions. But in this midterm, I gave you several conditions like this. This kind of chain inequality conditions. I give you at least two. Yeah, as I remember, at least two conditions like this. So you should do not use the equivalence condition. Okay? Yeah. Equivalence method. Yeah. All right. Number 15, the answer is 9. Yeah, the best answer is 9. The idea, yeah, so here, it's hard to give you the general method, two operation, square operation and cube operation, you need to try a little bit, okay? Yeah. Square operation, cube operation, and you try in a mixed way. Yeah. Certain mixed way. Yeah. Try a little bit and see if you can get the smallest possible number. Yeah. So the midterm part B, you will have a similar question like this. Yeah, that's number 15. Yeah. Next one. Number 16. Yeah. Number 16, similar. Yeah. Sorry, skip. Number 17, it looks fine. Yeah. Number 17, number 18, it looks like you did quite well. Yeah. You did quite well. I have nothing to explain. Yeah. Because in my hint, I already explained a lot. Yeah. So then you did, I didn't notice any error. Yeah. So no problem. So I do not need to explain. Yeah. But in our midterm question, I gave a similar question like this. Yeah. But in the new question, I give you 3 elements in place. Yeah. Here, 2 elements in place, right? In the new question, 3 elements in place. Yeah. But the method, the same method. Yeah. 2 or 3, yeah, similar way to answer. Yeah. All right. Yeah, number 19, pretty good. Yeah, pretty good. Yeah. Yeah. Some small problem. Yeah. But I do not need to explain here. Yeah. All right. Number 10. Yeah. Number 20. Yeah. Number 20. I saw 2 students didn't give me the correct answer. Yeah. The correct answer is 6. Yeah. Yeah. Some students give me too many, 9. Some too little, 3. Yeah. 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 2 steps. Yeah. So first you need to know the Pascal triangle. So you apply the binomial formula. So that's one part. Another is Horner's rule. So you calculate inside the parenthesis part. Yeah. 3 plus 3. Yeah. Each step, 3 multiplications. Yeah. Yeah. Pretty easy. Yeah. Yeah. So that's the part B part. 10 relatively easy computation questions. Part B. Yeah. Oh, I noticed some students, some students only give me one answer. Remember the partial credit thing? Yeah. Partial credit thing, yeah. So if you can give me some main work, yeah, not necessarily all the details. If you mainly show me the idea, how did you find the answers? If I can see your ideas, I can give you a partial credit. Yeah. But the one student I noticed missed many questions, but didn't give me any main work. In that way, that student lost many points. Yeah. Many points. Yeah. Just something, yeah, because for this midterm, if you want to earn more points, yeah, this is the place. Yeah. Because if you can, out of 4 points, if you can get 2 points back, that's really good. So 2 points here, 1 point there, so you can get back many points. Yeah. So that's one thing. For some of the students. Yeah. Yeah. For many other students, I saw the work. Yeah. So I just look at the work. Yeah. So I can make my decision. If the answer is wrong, then I check the work. If the answer is correct, yeah. Although I also look at the work a little bit, yeah. But I just give you full credit. All right. That's the part A part. Yeah. Oh, sorry, part B. Yeah, part B part. Yeah. Part C. Yeah. Part C. The challenging part. Yeah. The challenging part. Yeah. So this time. Yeah. Yeah. So I need to. Yeah, because that's the part I would really want you to solve some relatively hard questions. Yeah. Yeah. So yeah, the first one not hard. Yeah, although I put it in part C, yeah, but relatively easy. Yeah. So most of you know how to solve it. Most of you know how to solve it. So top 7, so how to solve it. But in our midterm, I modify. Yeah. So if I give you the similar questions, that's too easy. Okay. So I modified slightly. Yeah. So you need to make the connection. Yeah. Because here I only say one side. Top 7, only one side. Yeah. So for the new question, you will see in the midterm, part C, yeah, I look at both sides. Top part, top 2. Yeah. Then the bottom side, bottom 2. Bottom 2, yeah. Here, I only say 2 because in this case, not too hard to solve. Yeah. If I make top 3, not in top 3, not in bottom 3, so this is not part, okay? Not in top 2, not in bottom 2. So I need you to find one element in this part. The minimum number of comparisons. Slightly different. We have existing result. So when you work on this existing result, existing, we have one. You can use. Okay. Hope you can find it. You can find it. Yeah, but this existing result, yeah. So let me tell you, yeah, yeah, because, yeah, although because I said not in not in module 4. But this result is in module 4, part B. Module 4, part B, we have one result you can use on this question. Okay? Yeah. Although I try to avoid, but when I make questions, so I want to modify it, want to change it. Yeah. So here I give you the connection. You can look at the notes in this part. Try to find a related result you can use on this question. Yeah. Okay? Yeah. All right. Number 22. Answer is 13. Yeah, I noticed 2 or 3 students missed this one. Not partially correct, but not completely correct. Yeah. There are 2 parts. The first part, inside parenthesis. Inside parenthesis, Horner's rule. Yeah. Yeah. First part, Horner's rule. Yeah. Inside parenthesis. Right? Yeah. That part, yeah. I think all of you got this part. Yeah. But the second part, 2 or 3 of you missed the second part. Second part is the square sharing part. Square sharing. Square sharing part. Okay? Yeah. Because look at the exponent number. 6, 8, and 4. Lot of squares you can share. Yeah. One typical error. Yeah. So this error, I saw one student did that. Yeah. Yeah. But in my previous other semesters, many students did the same way. They calculate these exponent numbers separately. Okay? So they calculate, the first parenthesis, let me use U to represent. Second parenthesis, use V to represent. Third parenthesis, let me use W to represent. So they calculate U to the, those students use ABC, this capital ABC, same thing. Yeah. So U to the 6th, the number of multiplications. Okay? Yeah. V to the 8th, number of multiplications. Then W to the 4th, number of multiplication. The problem here is no sharing, no square sharing. No square sharing, that means you do not combine. Yeah. Because when we do square, if you can share the square, you can save one multiplication. Yeah. Let me show you one simple example. All right. Use the simple example, U squared times V squared. This simple one. Okay. All right. 2 different ways. The first way, no sharing. Second way, with sharing. You can see the difference. No sharing, 1 multiplication U squared, 1 multiplication V squared, then 1 multiplication between, you need 3 multiplications. Right? Yeah. But with sharing, you can combine 2 multiplications. U times V, the whole thing squared. With sharing, then you can save one multiplication. One here, but another one, another square multiplication will cover both u and v. That's the reason you can save. So this case, 2 multiplication. Yeah. So the same idea you can apply here. Yeah. You can share many squares. Yeah. So here I show you the idea you can use. Yeah. Because here I give you the logic for the sharing. Yeah. Because some students know to share squares. Yeah, I saw. But didn't share the maximum number of squares. Yeah. I saw one student just to share one fewer square. Then you need one more multiplication. One more than necessary. Not the minimum number of multiplications. That's why here I give you the basic logic for the square sharing. Because in the midterm you have a similar question for square sharing thing. Yeah. All right. Here, let me show you the process. U to the 6th times v to the 8th times w to the 4th. The first step. All right. Because the exponent, all even numbers, so we can take out one square to cover all these 3 monomials. So u cube v to the 4th w square, whole thing, 1 square, covering all 3 monomials. Then inside the next level, next level, you can see u monomial, w monomial, they have even exponent, but u monomial has odd monomial. Okay? Yeah, odd. So you can not take out 2, right? Yeah, but you do this way. You do this way. You take one u out. So that's exponent number 1 times, after that you have u square, right? You have u square. Then you have v to the 4th. Then you have w square. So these 3 monomials, they have even exponent numbers. You can do another square sharing, right? Yeah. So in this way, u times inside, u times v, sorry, v square times w square, another square. Yeah. Then, because u exponent 1, w exponent 1, v, so no chance to share more squares, right? Yeah, you cannot share furthermore, so you have to stop. Okay? Then you count. This square, that's 1 multiplication, first multiplication. Okay, all right. This square plus 1, second multiplication. This square plus another 1. Then 3 dots, right? 3 dots, 3 multiplication plus 3. Okay, yeah. Total 6. Yeah. Yeah. Adding together, you get 6 multiplications. Yeah. 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 That's the idea. So how do you share the squares in a greedy way? Here, a greedy way. Yeah. The best you can get. So that idea. Yeah. All right? Yeah. So try to do the best you can. For the midterm questions, I make these numbers slightly larger. Yeah. Larger than these three numbers. 10, yeah, a little larger. Yeah. But the idea, similar ideas. All right. Okay. Yeah, so that's these first two questions policy. Yeah. Then, next three. Yeah. So the question becomes harder and harder. Yeah. Yeah. This question, yeah, so not too hard, yeah, but a little tricky. Yeah. Yeah. A little tricky. Yeah. So, but I noticed the answer is two comparisons. A little tricky, two comparisons. Yeah, but I noticed more than one half. Total, you have 6 students, but my impression, 4 of 6 didn't get a whole question correctly. Yeah. So one I know got it correct, but probably there is another. Yeah. Yeah. Two students got it correct. Yeah. Yeah. So this question, if you get the insight, then not hard. But if you didn't get the insight, you may do too much work. Yeah. I saw one student did in 3 comparisons, and some other students even more, 5, 6. Yeah. Too many comparisons. Yeah. All right. So here, the first level understanding. Yeah. So there are 2 levels of understanding. The first level of understanding is handwriting not quite smooth. Yeah, first level understanding. Ooh. Yeah. Okay. Yeah. That's 3 comparisons. Okay. 3 comparison, that is at the most the first level. Yeah. So if you do more than 3, that means your thinking, so your method, your logic, too much far away from the correct solution. Yeah. 3, that means at least you are on the right direction. Yeah. So, but you didn't explore the given information enough. Yeah. So the second level understanding, then you need to really explore the given information. Take advantage of the given condition. So you get 2 comparisons. Yeah. So 2 levels. Yeah. So let me explain these 2 levels. Yeah. All right. Yeah. So let's do this way. Yeah. Because we only have these last 3 questions. After the last 3 questions, so we will finish. We will stop. Yeah. So let us take about 10-minute break. So then when you come back, we complete the remaining 3 questions. But when I break, I may like to use the 10-minute break time. I restart this computer, yeah, because I feel my handwriting too sluggish. Many times, response is very slow. Like I write this level, response too slow. So I think I need to restart my laptop to get it a little faster. Yeah. So let's take a 10. Yeah. So let's say right now. Let me look at the time. Yeah. Let's start our second half at let's say 45. How about that? Yeah. 6:45. Yeah. A little more than 10 minutes. Yeah. So take a break, and then I restart. Yeah. Otherwise, because I need to write a lot of handwriting. Yeah. If it's too slow, so then it's very hard to explain things. Yeah. So I try to restart it. All right. Yeah. Let's take a break.